Okay, so good morning. This is my review on chapter 37 and 38. So today we are going to talk about integral serialism. So, integral serialism. As you can see, this is a very advanced topic in music theory and it requires careful instruction, comprehension, and intricacy. The topic of this chapter discussed is we will be looking at expanded integral serialism techniques. And the goal for this chapter is so students can review basic set theory concepts such as normal and prime form, hexachordal combinatoriality, sorry, can't pronounce the word, and to identify other integral serialism techniques. Before teaching this concept to a classroom, teachers need to first have a basic background understanding of 12-tone operators. And the book uses this concept by analyzing a short musical excerpt from Gerhard's String Quartet No. 1, Movement 3, which contains various integral serial techniques. So where in the curriculum would this land? As you can see, it's an extremely complex topic, as this can most likely be found in the later parts of advanced music theory. I would classify this at least theory 4, but even early music theory students can come across difficulties when navigating set theory like serialism. This is why it's important to break it down narrowly so that they are able to utilize these abilities in the future. There are few curriculums in music universities that teach this topic in explicit detail. Texas State University has an elective course that briefly touches on the subject called Contemporary Analytics. So this is kind of a quick review on prime form. What is prime form? Prime form is the set of pitch classes that share the same collection of intervals, and they can be transposed or inverted to another pitch class set. Understanding the prime form will help us navigate assignments that involve 12-tone serialism. And this is kind of a cheat sheet from a YouTube video that I found, which breaks this down very well. Um, this is to understand the labeling and classification of pitch class notes. C is 0, C sharp is 1, D natural is 2, and so on. 10 and 11, A sharp and B, are also known as T and E. Now be careful of the enharmonic equivalence of set theory. Example, C sharp and D flat have enharmonic spelling, but they are both still considered 1. Before diving into prime forms, students and teachers should first understand the connections and the language before they perform any operations that involve set theory. Um, and this is another chart that I found, which kind of explains pitch class interval conversions. 0, perfect 1, 1, minor third, 6, tritone. And this is one example of the use of modular arithmetic. The intervals between the pitch class describe the space between two pitches. In set theory, we use numbers to describe intervallic space. Pitch class interval counts upward from one pitch class to another pitch class. To get the interval, we subtract the number of the lower pitch class from the number of the higher pitch class. So in this case, the distance between two, which is D and F sharp, which is 6 and 4. There are 4 semitones between 2 and 6 in this example below. Set theory uses mode 12 as there are 12 numeral values. To find the interval distance between our pitch class numbers, we add or subtract from the numeral value of 12 to solve set theory math. There are instances where we might come across where we subtract to find the interval distance, we may get negative. As you can see, 4 subtracted from 9 is minus 5, but that is not the distance and there is no such thing. To figure this out, we use modular arithmetic of 12 to figure. We add 4 to 12 to get 16, and then we subtract 9 from 16 where we get 7. There are 7 semitones between A and E. Oh, and this is also a chart on hexachordal combinatoriality and a quick little review for students to understand. And now this is kind of my little analysis of the musical excerpt, and the teacher should give the student some time to identify the pitch classes in the first 2 hexachords marked in this musical excerpt. I labeled the first one, and how they would identify the pitch classes, and then they would put it in normal order. The first answer they should get is 0, 1, 2, 4, 6, 8, and this is where they put it in normal order. These are all the pitch classes in the whole tone scale 0 members. The teacher can also ask the student how many whole tones do they recognize, and this is kind of an idea of how students can analyze and figure out the pitch classes. You can look up the answers in the book. Once the students get an idea, ask them to make a matrix so they can analyze the third movement of the Gerhard musical excerpt. This is the first movement. So, hexachords. With the three hexachords, ask students to find the prime form, ask them to locate the normal order of the first hexachord. Each set contains a whole note collection. And the first set, I already said. The second set would contain of the second hexachord contains 3, 5, 7, 9, and 11.2. Oh, and this is also an example of a 12-tone matrix of what it would basically look like. The previous chapters in the book also have discussions on how to make a matrix. Students use a matrix to solve or discover row tones. Once students are done creating their matrix, ask them if they can see any combinatorial properties. Students should discover that each row they create has a combinatorial pairing. They should also be able to locate any pairs that are potentially inversionally combinatorial row pairs. After explaining and understanding the basic features of a row and labeling the hexachords, ask them to complete a row count of the musical excerpt. So before analyzing the musical excerpt, give the students some time in class to complete their matrix. Now this is where the classroom uses a matrix to solve the row count and identify the complementary pair. Once students are done analyzing, ask them questions like why the composer chose this specific order. Are there any observations you can point out about the score, like why is there a missing time signature and what musical elements could be serialized? According to the book, this approach to serialism of duration gives Gerhard more compositional freedom as he's able to manipulate the rhythmic content rather than commit to a series of rhythmic durations. So why this example? Well, this example serves as an excellent introduction to integral serialism techniques as it clearly illustrates the serialized pitch and durational elements by showing how many tone rows are used to determine the order in which rows appear. The third movement of Gerhard's String Quartet No. 1 provides ample opportunity to students for a review of set theory concepts. And according to the book, they can review normal order, prime form, and subset such structures before they get into 12-tone, such as matrix building. And his serialism, Gerhard, differs from other composers such as Babbitt, Boulage, and Stockhausen, so this gives an opportunity for the teacher to discuss experimentation and differences in philosophy in post-World War era and how that's showcased in the music. So that's my analysis on chapter 37. We're going to move on to chapter 38, mapping symmetry and form. In this chapter, we'll be looking at mapping symmetry and form, and the topic is a graphic analysis of George Crumb's A Prophecy of Nostradamus from Book 2 of the Macrocosmos, composed in 1973. The goal was for students to analyze the work while using a structural template that reveals their discoveries on topics such as pitch relationship and symmetrical structure. According to this chapter, students should have a background on pitch class set, Gregorian chant, harmonic analysis, form, familiarity with C-clef, symmetrical pitch properties, prime numbers, and extended technique. So as you can see, there are many challenges that will arise. Post-tonal analysis poses a challenge for both undergraduate music theory students, but also teachers, as the familiarity with the repertoire that introduces these ideas are little to known. Crumb's musical excerpt, which we will look at later, offers a clear example on the manipulation of pitch, form, rhythm, and symmetry. This work contains intertextual and extra music associations that give students the opportunity to develop their own aesthetic analysis. So the teaching approach. First, students should analyze the musical parameter, then they transfer their findings to a symmetrical structure format, revealing the concept of content as form. This piece can be used as an analytical tool as it features triadic harmony, simple melodic and rhythmic content, together with clear symmetrical design. involves use of cognitive skills, critical thinking, pattern creation, and problem solving. I would create a lesson plan to guide students on what to look out for and how to approach it. So the analytical analysis, play the piece once in class with the score in front. According to the textbook, to analyze the work, the teachers should split the class in two groups. Group A analyzes sections A to C. Group B does the same with sections D to F. Students should analyze pitch content and write the answers of the template. They should also find a partner from the opposite group to compare their answers. Then the teacher calls on the students to reveal their analytical findings. So, some preparation. This level is suitable for advanced undergraduate music theory students studying form and analysis. It would probably be better to take this course in their later years, preferably after they finish the required theory level core curriculum or at the start of grad level studies. Students should research this piece individually and then analyze the work before presenting in class their findings. They should carefully listen to the Crumb excerpt while analyzing the score in front of them. Consider the questions, who was Nostradamus? What is the melody like? And search for other similar repertoire, such as Debussy's Preludes for Piano Books 1 and 2, so they can compare and find similarities of the style. And then they should study the manuscript score design and shape. For the teacher, I would do a little bit of research about the composer George Crumb, who was an American composer in the 20th century. He created mixed chamber ensembles, solo piano, and vocal chamber works. Focus on his aesthetics. And Crumb's Macrocosmos took inspiration from Debussy Preludes and Bartók's Macrocosmos, titled the same, so there will be similarity among the works. And this is kind of an example of a structural analysis, which can be found in the supplemental materials. Okay, with all of that in mind, I am going to play the musical work, and this is what the score looks like. George Crumb's A Prophecy of Nostradamus from Book 2. Before we do any analysis of the work, find a recording on YouTube and listen to the musical piece before you let students come up with their own analysis and discoveries. So I'm going to play it. That's all we're going to listen to for now. Um, so, any extended performance techniques and analytical analysis they can find. On first listen, The composer makes use of keyboard extremes with his major dynamic contrast between the quadruple marked fortissimo and quadruple pianissimo markings. There's a very weird symmetrical shaping of the score, and Crumb intends to ask players to silently depress left-hand chords to get that effect. His notation of PI indicates the use of damper pedal. All sections are played in an attacca manner. The use of echo chords and pedal indications are also in effect. There's a lot of tenuto and stark contrast of dynamics. One of the extended techniques is the use of piano as a resonating instrument, and students should take note of the technique where you can hear the strings of the loud chord compressed. There is use of the Dies Irae Gregorian chant, association with death. And for pitch behavior, there are incomplete pitch collections. Other discoveries. According to the chapters, students should make these possible discoveries on the excerpt, like the form, symmetrical form. And the book says it's an exact palindrome around a central axis of the Dies Irae melody. I'll show it one more time. This is what it looks like. Graphic score performed in retrograde order. There's a mirror image score that must be turned at a 180-degree angle at the midpoint to see the whole thing. So as you can see, the score is upside down and it needs to be turned around so you can see the whole thing. Very unusual. Dynamic contour, set class relationship and usage of tritones, numerological associations, prime numbers that are used for time signature. And as I said, there's the relationship of tritones between chordal pairs, which is the incomplete pitch collections. And some in-depth class discussion. An undergraduate class learning this concept can look at the piece by summarizing the symmetrical properties of the graphic score, apply their pitch content analysis, and they can use the template to support their points. Graduate level class should further extend their analysis on a deeper level by considering the symmetrical procedures of the form, time signature, the proportional relationship between sections, and numeral numbers. And some examples from the book say, only time signatures are used in 13/4, 11/4, and 7/8, all prime numbers. The pattern of chordal attacks in sections A to F is based on the prime numbers, these ones. And yeah, so that is my review on chapters 37 and 38. Thank you.